All right, here's a really simple example of how to do a real simple conservation of energy equation, okay? A pendulum where the bob is made from a 0.32 kilogram ball of clay is released from rest. At the bottom of its swing, it hits and sticks to a wall. The release point is 0.25 meters above the lowest point in the swing, okay? All right, so what we're going to do is we're going to set this as the 0 level, okay, so that we know this height here, all right? Okay, so this is convenient because we're given that height. Sometimes you're not given that, just as a warning, right? You're given the angle and the length of the bob, okay? And then you have to, this is also the length, right? Then you have to use some trig to figure out this value, okay? But you can probably figure that out. Okay, all right. So first thing I want to do is put what's in my system. So I'm going to put the pendulum, the wall, and the earth, I think. Okay, and you need to pick the two positions that you're going to work with, all right? Because there's infinite number of places that you can choose the analysis, but you need to choose places that are smart, okay? So the first place would probably be top of the swing, okay? And then for part A, it's asking how fast is it moving right before it hits the wall, okay? So as hits wall, okay? So you want to pick somewhere that's something that you want to know. All right, so here I'm going to have a certain amount of gravitational energy. Nothing's coming in or out of the system. That's all turning into the kinetic energy. Everything else is nothing. We'll assume no air resistance and no thermal because it hasn't hit the wall yet. Okay. All right. So you're just going to set up your equation, UG initial equals K final. Okay. And then you just have to plug in the values, okay, with your equations. Okay. So you're going to substitute in your equations there. The mass cancels, which it often does, so watch out for that, okay? And so my VF is going to equal 2GH radical. So radical 2, I'm just going to use 10, and it was 0.25 above. Okay, so the final velocity as it hits the wall is 20 times 0.2. Oh, this is I could have done in my head. Oh, no, maybe not. Divided by, I don't know, radical. 2.2 meters per second. Okay. I mean, so that's like a real simple one, right? So that could be like a multiple choicey kind of question. Okay. All right. What I want to do then is I want to think about what is the increase in thermal energy once the pendulum is stuck to the wall. Okay. So it doesn't matter. I'm just going to go from the top again. Okay. Although you could do this, right? Because it doesn't really matter what you pick for this position. Okay. But now whatever energy I had is going to turn into thermal, okay? If you wanted to, right, you could have just done that one as your initial position, that one right there, okay? But it doesn't really matter because you can compare any 2 points, okay? Delta E thermal, okay? So I just need to know the MGH, right, which was the number that I had probably under this radical, right? 210.25, which was 5 joules. Okay. So that's the total amount of energy in the system. It didn't go anywhere, right? If I started with 5 joules here, it had 5 joules as it hit the wall. It had 5 joules when it was done smacking into the wall. So 5 joules of energy were dissipated. Okay. All right. So that's a quick example. So what I'm hoping is after that, you'll be able to probably do that one maybe later. I don't know. I might make a video if I have time. And then I'm hoping that you're going to try these activities, which is kind of doing this simple analysis, but with some measurements. Okay. In activity 1, 2, and 3. Okay. And then there's a couple more examples. I'll put a video for that one. And then some tippers, tasks, and a WebAssign. Okay. And there's some other videos also on this last page. That's not it, but on ClassKick, there's some other video examples.